So we'll study the monohybrid cross, children. Monohybrid cross, as explained by Mendel, who did his experiments on the pea plant that we've already discussed. Here he took the physical character, that is the height. So he focused on the height, and what he did was he crossed the tall pea plants with the dwarf pea plants. Now tall he represented by capital T, and dwarf was represented by small t, small t. Now a question arises, why should we take two of these? Why not one? Why can't we simply take a single t? The reason for that is, if we remember the chapter from the chapter reproduction, that the chromosomes are always in pairs. Hence, these have to be taken in pairs. Right? So we can call them as the parental generation. These were the parents. Right? So, parental generation. Now, found out the gametes. Obviously, the gametes will not vary. Right? These were the gametes of the parents. So, I'll just write gametes also so that it is clear to you. Now, he cross-pollinated. Again, cross-pollination is a term that we have read and understood well before. Now, he cross-pollinated one of the parental generation, one of the generation to the other. So, let's say this T with this T. Again, the same T has to be crossed with the other. Similarly, now we focus on this with this, and again this with this. So this is just a little mathematical. So these are the F1 generations. F1 generation. Right? So F1 generation, if we say, when we talk about genotypes, what is a genotype? Genotype is nothing but the genes responsible for a particular trait. So what are genotypes here? These are all genotypes. So since they are all similar, we can say that the genotype is this. Normally, capital is a letter that is used for a dominant trait, and small letter is used for a recessive trait. Now, wherever there is a dominant trait with the recessive trait, that means that this will express itself, whereas this will stay in the recessive form. So, if we say F1 generation, all of them are tall. You can see that a capital T arises in all these four. So, the genotype is capital T, small t, and the phenotype, we say, is all tall. All are tall plants. So in the F1 generation, we found that all of them are tall plants. Now let's move across. If we take them as the parents in the second generation, if we say these are the parents now, this is the parental generation. In the second one, there was a self-pollination. So again, moving to the gametes. Right? Now, I'll just draw a square here that's called a Punnett square. Nothing technical here. One, I'm writing on this side. The other set, I'm writing on this side. Right? Again, like we crossed here, T and T, both capitals. Capital T with small t. This small t with capital T. I have used capital T before the small t. It can be used vice versa. The reason why I use this is to represent that this is a dominant trait. And here we have small t, small t. Now, if we clearly see 1, 2, 3. All these three have at least one capital T. That means tall, there are 3:1 ratio, tall is to dwarf. So we can say that the ratio is 3:1. This is our F2 generation, remember. Okay, this is our F2 generation and we have the ratio 3:1. This 3:1 is nothing but 3 of them are tall, whereas 1 is dwarf. We can also say TT. We learned the word homozygous and heterozygous. We can say TT is homozygous tall. Okay. Whereas T, capital T and small t, these are tall, but these are heterozygous tall because they have the recessive trait as the dwarfness. And one is small t, that is homozygous but homozygous dwarf. This is what the monohybrid cross is. So these are the parental generations. I'm quickly going through it. These were the gametes of these parents, right? And then a cross pollination took place where the F1 generation that we got was all these plants were tall, right? Similarly, if we take them as the parents for the next generation, obviously for the next generation, these will be the parents. They were self-crossed. These were the gametes of the second generation. And then this is called the Punnett square, where we took one on the other one side, you can say male here and female here. Female, this is represented by this represents the male and this represents the female. Again, crossing over and we get the result as 3:1. This is the explanation for your monohybrid cross. Next, I will add a video that represents the dihybrid cross.